Okay, so this is the continuation of the lesson on section 2.2, Cushier arithmetic. We talked about addition, subtraction, and halving. Now we are going to look at multiplication and division. So again, we are going to illustrate his algorithms through examples. So for multiplication, let us consider multiplying the numbers, say 432 times 36. Okay, so he is going to put the numbers in two rows, but okay, this time, okay, he's putting the numbers in two rows like this. 36 goes to the bottom row like that, and the placement of the numbers is not arbitrary here, and it shows a thorough understanding of the decimal system. So the reason the numbers are placed like this is as follows. So this number on the top is in hundreds, so it is a number in hundreds, and we are multiplying it with a number in tens, right? 36 is a number in tens, and the result is a number in thousands at least. So here we start accumulating the numbers, the answer starting at this position here, above the leftmost digit of the bottom number. And this is the thousandth positions. And of course, it could be greater than 1,000, it can be 10,000. So if necessary, we'll go to the left as well. Okay. So in this process, there will be three stages called shifts, and the number of shifts will be equal to the number of digits of the top number. So in this case, there are 3 digits on the top, so there will be 3 shifts in this multiplication. So let's start with the first shift. The first shift. Okay, so we start with, so in each shift, we'll be working with 1 digit of the upper top number, starting with the leftmost digit. So we start with digit 4, and we multiply this digit with each digit of the number on the bottom. Okay, we start with multiplying 4 times 3, which is 12. So if the result was a single digit, we would place it here. But when it is 2 digits, more than 10, we need to go 1 more digit to the left. So we go like this. Okay. So we have 4 times 3 is 12. So we put 12 here, and then 36 down here. Now we reach the end of the shift when we multiply the current digit of the top number with the unit digit of the bottom number. So since the bottom number is only 2 digits, we reach the end of the shift after 2 steps. So now we multiply 4 times 6, 24. So now we are going to replace this digit with 24. Now, if this multiplication, if the result here were a single digit, we would simply replace 4 by that digit. Okay, so for example, if it was 4 times 2, if it was, then the result would be 8, and we would replace 4 by 8. Now, when it is 2 digits, what we do is this 2 we add to the digit to the left of 4. So that means that we would increase this 2 by 4. So therefore we would get 1, 4, 4, 3, 2, and 36. See, at the end of the shift, we do a replacement. Okay, so the units digit of the product happens to be the same as the digit we are replacing with, the digit being replaced. So in this case, it didn't change, but be careful, when the result is greater than 10, we need to go to the digit on the left and increase it by that digit. So now we move to the second shift. Okay. So what we do in the second shift is we take this result, okay, from the first shift, but we shift the bottom number to the right, okay, so that its units is aligned with the next digit we are going to work with. So next we are going to work with the digit 3, the next digit of the original number. Okay, so what we do is we multiply 3 and 3, so 3 times 3 is 9, and we add it to 4, or we add it to 44, When the result is going to be greater than 10, we add to the 2-digit number, going 1 digit to the left. So 44 plus 9 is 53. So therefore we are going to have 1, 5, 3, 3, 2, and then 3, 6. So again, we are still working with this, and we now multiply. So first we multiply this 3 with the leftmost digit of the bottom number. Now we are going to multiply it with the next digit of the bottom number. So in this case, 3 times 6 is 18. And remember, we are at the end of the shift, so we need to replace. We need to replace this 3 by 18. Now, how do you do that? Well, you put 8 in place of 3, and we increase the digit to the left of 3 by 1. So therefore, we get 1, 5, 4, 8, 2, and 36. So this is the end of shift 2. Now we move to the third shift. Okay, we take the result from the second shift, except that we move the bottom number to the right, and now the multiplier will be the unit digit of the top number, 2. So okay, so now we'll multiply 2 by 3 and then by 6. And we repeat the same things that we did before. So 2 times 3 is 6, of course. And we add 6 to 8 or 48. So we add 6 to 48. The result is 54. So we get 1, 5. So 48 will be replaced by 54 and 2 and 36. Now we are almost done. We multiply 2 and 6, which is 12, and then now we need to replace this 2 by 12. Well, how do you do that? 2 is replaced by 2, and this 1 is added to the digit to the left of 2. So therefore we get 1, 5, 5, 5, 2, 36. And at the end of this shift, we get the final answer, which is 15,552. All right. Okay. So you know that multiplication is a commutative operation. That is, it doesn't matter in which order you do this. So as an exercise for yourself, so do the same multiplication in the opposite order. Do this in the opposite order. That is, put the 36 on the top and 432 on the bottom. Okay, so this would be a good exercise for you to practice this algorithm. and you should get the same answer at the end, of course. Okay, so now let's move to division. Okay, so now let's consider the example of dividing. So divide 8,743 by 28. Okay, so Kushar again places these numbers in two rows and aligned from the left like this. Okay, so now the top number will change, but the answer will be obtained on top of this first number here of the dividend. Okay, and notice that this is in thousands. So thousands divided by tens is in hundreds, right? So the answer should be in hundreds. So therefore the answer, the leftmost digit of the answer will go here. Okay. All right. So the first step is to find out how many times 28 goes into 83. And by inspection, you can see that it goes into 87 three times. Okay. So what we need to do now, I mean, this is similar to really, the division that you learned in school, right? So, you do inspection and you figure that 28 goes to 87 three times. So you compute 28 times 3, which is 84, and you subtract that from 87, which is 3. So therefore, you get, so 87 now will be replaced by just 3. And then we have 3 on the top part of the answer. So highest digit of the answer of the quotient is 3. So what we do next is similar to the shifting. This is really first shift. So we do a second shift where we shift the divisor to the right like this, and 3 is the first digit of the answer. So now we ask how many times 28 goes into 34, and it is obviously just once, right? So that means that the next digit of the answer is 1. By the way, over here, this 3 is really 300, right? And it really represents the fact that 28 goes into 8700 300 times. Okay, you can also look at it that way. And also here, this 34 is really 3400, and this one is 10. So this represents the fact that 28 goes into 3410 times. Okay. So we simply subtract 128 from 34, and the result is 6. So this 34 just is simply replaced by 6. That, and we have 3 and 1 on the top. Okay, so then we do one more shift. Again, where we move the bottom number to the right. And we ask now how many times 28 goes into 63. And it is easy to see that it goes 2 times. And then we subtract, we multiply 28 and 2, which is 56. and subtract that from 63, which is 7. So we get so the number on the top, this number, which is the dividend, just reduces to 7, and the divisor does not change, and the answer is 312. So once this dividend becomes less than the divisor, we stop and we say that 8,743 divided by 28 is 312, and then there is a remainder of 7, right? So this is 312 is the quotient and 7 is the remainder, so we can write it this way. Now, if we interpret this division as dividing this many dirhams among 28 people, that means that each person gets 312 dirhams, and then there is 7 dirhams left over, right? Now, if you want to divide this further, using flus, you may ask, how do I distribute 7 dirhams among 28 people? Well, so you ask, how many flus does each person get? So to figure that out, you can set a proportion. You can say 7 out of 28 is the same as what? N over 60, all right? So to solve for n, you do cross multiplication, and you can see that you can easily figure out that n should be equal to 15. So that means that each person now gets 312 dirhams and 15 flus. Okay. Now, if you look at the example in the book, in that example, 5,625 is divided by 243, and the quotient is 23, and the remainder is 36. Now, again, if you interpret this in terms of dirhams, dividing this many dirhams among 243 people, so each gets 23 dirhams, and there is 36 dirhams left over. So if you ask the same question, if you distribute further 36 dirhams among 243 people, how many flus does each person get? So you can set this proportion, and you can solve this for n. Now this time it will be a little more complicated. So n will be equal to this, 2,160 divided by 243, and this gives you a quotient of 8 and a remainder of 216. So this means that each person gets an additional of 8 flus, but then there is still 216 flus left over, right? So in practical terms, you can, there is no lower, unit of money to distribute this even further. However, you can imagine doing this theoretically. You can keep doing this. You can keep going 216 over 243. What is that out of 60? You can ask this question and solve for n, and effectively obtain, more digits for this number for the fractional part. So basically, this means that if you write this number in base 60, again we'll learn more about it later, it means that the whole part is 23, and the first digit of the fractional part is 8. And if you keep going with this process, you can obtain more digits for it. Okay, so we'll come back to this later in the course. So for now, we'll stop here, and this is a small introduction to sexagesimal arithmetic.